Okay, this video is on using logarithms to solve exponential equations. Now, we already know how to solve many kinds of exponential equations even without using logarithms, just by using this simple rule. If a number to a power equals that same number to another power, then the two powers are equal. And we've used this in a lot of different equations to solve. Like, for example, this right here. I've got 5 to the x times 5 squared equals 5 to the 7. Well, my base here for each one of these expressions is 5. And in fact, this 5 to the x times 5 squared, I can rewrite that using just one base because I can use my rule that says if I'm multiplying two numbers together that have the same base, I write down the base and I just add the exponents. So that would be 5 to the power of x plus 2 equals 5 to the power of 7. Well, now I can see that I have exactly this situation right here. I've got a number raised to a power equals that same number raised to a different power. So I know, therefore, that the two powers, that is, these two exponent values, have to be equal. So I can just take this and I can set the exponents equal to each other. So x plus 2 equals 7. And now I have a simple equation that I can solve. Subtract 2 from both sides, and I have x equals 5. Well, I can do that with these equations also because, even though it may not look like it, I actually have exactly this situation. Notice that here I have an expression that has 10 as its base. And on this side, on the right side, 1,000, I can express that number as a power of 10 also. 1,000 is equal to 10 to the third power. Well, once again, I have this situation. A number to a power equals that same number to another power. So that means I can just set those exponents equal to each other. X equals 3, and I've solved that exponential equation. Now, pause the video right here and see if you can use this same rule here on examples B and C, and then come back and see if you got the same answers that I got. So once again, I have 1,000 that I've written as a power of 10, 10 to the third power. So again, I have a number raised to a power equals that same number raised to a power, and I can set the exponents equal, just like using this rule up here. So I set the exponents equal to each other, and I get x equals 1. Once again, I'm essentially doing the same thing. I'm expressing this as a power of 10. Now I have both sides of my equation are 10 raised to some power. I can set the powers equal to each other, and then I just solve it using my other algebraic tools that I have. So now let's try a couple more examples like these. So example D here. Here I see I've got a power of 10 here, but I don't have a power of 10 on this side until I divide both sides of my equation by 2. So if I divide both sides of my equation by 2, now I've got 10 to the power of x. 200 divided by 2 is 100. And 100 I can express as a power of 10. So I've got 10 to the x equals 10 squared. I set my exponents equal, and I've got x equals 2. Once again over here, I can divide both sides of my equation by 3. That will get rid of this number 3 on this side. They cancel out. And I now have 10 to the x plus 4 equals 3,000 divided by 3 is 1,000. And again, I can express 1,000 as 10 to the third power. I can set my exponents equal to each other. That gives me x plus 4 equals 3. I subtract 4 from both sides, and I get x equals negative 1. So this all works fine if I can get both sides of my equation expressed as a power of 10. But what if I can only get one side of my equation expressed as a power of 10? Well, if that's the case, then I'm going to need to use logarithms to solve my equation. Now remember, the definition of a logarithm says if y equals 10 to the x, then I can say the log, using base 10, the log base 10 of y is equal to x. So I can use this rule, I can use this definition of logarithms to solve these equations. And let's take a look at what that's going to be like. So here I have 10 to the power of 2x equals 50. 50 I cannot express as a power of 10, so I want to rewrite this using this definition of logarithms. And actually, before I do that, let me kind of turn this around. Let me write this. I'm going to put 50 on this side and 10 to the 2x on this side. So I have a number here which is equal to 10 to a power. Well, that means I can rewrite this expression in this form. Specifically, I can write it as log base 10 of my number here, 50. The log base 10 of my number equals my exponent, the exponent of 10. And look at what happened here. All I did was, my exponent here came down to this side of the equation. My base, which is 10, that's the base of my logarithm expression. And this number here, 50, that comes right here. That's like the y value in my exponential expression. Well, now I can take my calculator, and I've got a button on my calculator that I can use to calculate the logarithm in base 10 of 50. So if I punch that in my calculator, I get approximately 1.699, and that's equal to 2x. Well, now I just need to divide both sides by 2, and I get x equals approximately 0.8495. Let's take a look at example G. All right, again, I've got 10 to a power on one side, and I've got a number on the other side. Let me put my number on this side. 43 equals 10 to the 3x plus 2. Again, I just want to rewrite this exponential expression as a logarithmic expression. So I'm going to write log base 10. All right, again, here's where my 10 goes. Log base 10 of this number, 43, equals my exponent, which is 3x plus 2. Now I can punch this value into my calculator and get an actual number for the log base 10 of 43. And if I punch that in my calculator, I get approximately 1.6335. So this is equal to 1.6335, and on this side I have 3x plus 2. Now I can solve the rest of that equation just using regular algebra. Subtract 2 from both sides. 1.6335 minus 2 is negative 0.3665. Divide both sides by 3, and I get x equals negative 0.1222. All right, let's try this one. Now here, I'm going to have to do a little bit of algebraic manipulation before I've got it in this form. If I add 7 to both sides, excuse me, if I subtract 7 from both sides, my 7's go away, and I've got 3 times 10 to the power of x plus 4 equals 21. Now if I divide both sides by 3, then my 3 is going to go away over here, and I've got 10 to the power of x plus 4 equals 7. Now I have it in this form, which means I can change it into a logarithmic form. So let's see. Log, my 10 is my base, so it's going to go here. 7 is the number, that's my y number here, so 7 goes here. And my exponent, x plus 4, goes over here. If I punch this into my calculator, I get 0.8451 approximately. On this side of the equation, I have x plus 4. Now I subtract 4 from both sides, and I get x equals negative 3.155.